Good morning and welcome to Managerial Accounting. Hope you had a good week off from accounting. As I indicated before I started recording, review is open on our first exam, so please make sure you go through that. And if you have anything you want to go over, I'm happy to meet with you or work with you by email and go over any questions you might have from the exam. It is your responsibility to go into CNOW. One way to get to the exam itself is to go into the grade book and hover over the grade, and you'll see that it's clickable. If you click on the grade, it will bring up your exam. It's the same process that you use for reviewing your exercises and your problems, so hopefully you're already familiar with that process. So please make sure you go over the exam and let me know if there's anything you want to go over. I'm happy to do that. As we look at our calendar then, today we're going to be finishing up chapter 19. So we'll be starting with exercise 6, which is another example of reciprocal services method. And we'll do that together. And then we'll be shifting to the joint cost allocation, which is kind of the second half of the chapter. So there are 4 methods that we'll be going over. We have 1 exercise for each of those 4 methods. And then by the end of the day, you should be submitting those chapter 19 exercises for grading. We will have done all of them together with the exception of 4 and 5, which were review of the first 2, the direct and step down methods for allocating support department costs. And so I asked you to do those last week. I had asked you to do those on your own. So we're not doing those together, although I will be happy to answer any questions you might have about those in a minute. So we'll be finishing chapter 19 today, next week, chapter 20, the following week, chapter 21, as well as the research for your project. We've talked about this in an earlier class. I'm not going to belabor that, but if you do have questions about what you're supposed to be doing, please let me know. All you need to do for that step 2 is submit 3 sources. 1 is going to be the company itself. You need 2 additional sources that are not the company. And then you need to give me just a brief, couple sentences to tell me how each of those sources is going to be helpful for the project. So as I explained before, what I would suggest you do is open the directions for the project, see what kind of information do I need, and then go try to find that information. That should be the best approach to finding your sources. You need 3 different sources to get full credit for the research step. You are not then tied to using only those 3 sources. If you, as you're working on the project, realize, oh, I need some more information about this, or this isn't the best source, you are welcome and encouraged to continue to gather additional information and use more than just those 3 sources. But the purpose of that intermediate step 2 is just to make sure that you're going to be able to find the information you need to get people working on it before the day before it's due. Believe me, it's happened. The day before it's due, I've got people saying, I can't find any information about my company. Not that I'm unsympathetic, but my first thought is, but you chose the company. So why didn't you learn this earlier? I learned from my mistakes. And so now there's that step in there that you have to do the research in advance of when the project is due. Also on March 9th, so March sounds to me like it's a long ways away, but it actually is next Tuesday. Our next class will be on March 1st. So March 9th, we faculty will be submitting 6-week grades. So one of the reasons that most of you have seen a note from Starfish yesterday related to your progress in this course, specifically triggered by exam 1, is because those 6-week grades are coming up. And the major part of your 6-week grade will be the exam. So I'm just preparing you, if you didn't do as well as you would have liked on that exam, your 6-week grade will reflect that. But as I said before class started, there's lots of time to bring your grade up. There's lots of opportunity left. There's 3 more exams, 9 more chapters after this one. The project is worth basically an exam grade. And so there's lots of time to bring your grade up, but you need to figure out what you can do better if you're not happy with your grade where it is right now. I'm not suggesting what your grade should be. You know, some people will be happy that, hey, I made it through the class. This isn't my bailiwick, and I'm just glad that I made it. And some people are not going to be happy with a 92 average. So wherever you come on that spectrum, if you're not happy with where you are right now, give it some thought. If you want to talk to me about what your options are, what might be helpful for you, ultimately you're the best source of knowing what's going to work for you and what might be helpful. But I'm happy to contribute to the extent that I can. One thing I was talking about with a student in the class last week is scheduling about weekly, I'm going to call them review sessions, but that's not really what it's about. My thought is to have a time, and I'll change the time maybe each week so it's on a different day or different time of day, to hopefully capture as many people as are interested in attending, but so that we can work through issues related to that chapter. So the idea would be that as we're working on the chapter, but before the homework problem is due, we would have a meeting, and I would, of course, be happy to record those and make those meetings available just in case it doesn't fit in your schedule, because we all have different schedules. And I know most of you are very, very busy, don't have a lot of free time. So, watch for those. I'll put them in the announcements, and what I will be doing is scheduling them in Starfish. There's a way for me to schedule a group session, and you don't have to be registered or signed up to attend, but it would be helpful if you did that so that I have a sense of why people are coming and how many people to expect. So watch for those. I'll put them in the announcements, and then you'll be able to sign up in Starfish. Looking at the reference materials for chapter 19, you'll notice that there is a tutorial for the mastery problem, as there has been for the last couple chapters. So this mastery problem is also a little bit more challenging. I think after this, they get a little bit easier or less comprehensive in nature, maybe. There's just not so much to them. I think this is maybe the last chapter that it's kind of an overwhelming problem. And so there is a tutorial here. You are welcome to use that if you find it helpful. If you don't, that's fine. But if you try the problem on your own and you get stuck, that should be your first line of defense, is to use this video and let me know how I can help. Okay, any questions about where we are, what's coming up, what's due, anything else? All right, I will take that as a no. So let's go to See Now for chapter 19. These are the chapter 19 exercises. As I said last week, and I repeated at the beginning of class, last week we did exercises 1, 2, and 3 together. I'm just reminding you because it's been a full week since we did this. So we looked at the direct method, the step down or sequential method, and the reciprocal services method. And then I asked you to try exercise 4 to practice the direct method, try exercise 5 to practice the step down or sequential method. Does anyone have any questions about either of those exercises? Okay. If you haven't had a chance to try those yet on your own, then you're working on them later and get stuck. As I pointed out last class, both of them have the Show Me How button. You're welcome to use that. The Check My Work button. But if you really, excuse me, need some assistance to go through that, just let me know. Just because I've given you the opportunity now to ask questions doesn't mean you can't ask questions again later if you have them. And we will pick up then, since nobody's asking any questions now, we will pick up with exercise 6. So again, because it's been a week, I'm going to remind you this reciprocal services method, although it is the most accurate of the 3 methods that we're using, it is also the most difficult to implement. And so for that reason, because it's hard, because it's difficult to implement, it is not something we would do unless we get meaningfully different or materially different results. We would want to use the simplest method possible that still gives us an accurate sense of our costs for producing our product and running our business. As I explained last week when we introduced this, and we saw that it's really a system of equations in 2 variables, and we have to solve for the substitute one into the other and solve and so on. As I explained last week, because it is more challenging, because it really is an algebra thing, I think, for many people, more so than I don't understand the accounting. I don't understand why we're doing this. I think for most people, you get what's happening, but maybe not how to implement that. And so for that reason, it is not on the test, but it is the extra credit problem that is, of course, optional. It's extra credit that goes with our next test, which will be coming up in a couple weeks. So I would prefer that everybody understands how to do it and is able to implement this method. But if it just gives you anxiety even to think about it, to hear the word algebra associated with accounting, I don't want anyone to be concerned or panicky about that, because it's not on the test. So, but we are going to go through it again here. I told you last week that we would do this one together so that you can see how, one more time, how this works. Before I start this exercise though, is there anything anyone wants to ask about?
I just wanted to double check. I believe you said for the reciprocal method, we need 2 of each, 2 support and then 2 production.
We'll be doing 2, yeah. That's
Okay.
the only thing we will be doing is a 2x2.
Okay.
Because we're not doing any more than 2 variables. So if there was only 1, there's no other system of allocating it. I mean, it's, you've got 1 support going to 2 or 7 or 20,
yeah.
You're picking 1 method, right? So for our purposes, we're only doing 2x2. Yeah, 2 support, 2 manufacturing or production departments. Yes. May not be realistic. Most companies probably have more than 2 support departments and more than 2 production departments, probably, but that's what we'll be doing. We only want 2 variables to deal with. That's enough. So I think to lead into this exercise, I will just remind you, so the direct method would look like this. We have 2 support departments. Let me get my annotate function up here. And I'm going to divide these. So we have 2 support departments, janitorial and cafeteria. We have 2 production departments, cutting and assembly. If we were using the direct method, it would look like this. We take the $310,000 from the janitorial department and we allocate it to the cutting department and we allocate it to the assembly department. And then we take the $169,000 from the cafeteria department and we allocate it to the cutting department and we allocate it to the assembly department. It's direct because we don't allocate support departments to any other support departments. It goes directly to production. Do not pass go, just go directly to production. That is the direct method. It's the easiest one, it's the fewest steps. From there, we went to the sequential or the step down method. And in the step down method, we look at the 2 support departments and we say, you know what? The cafeteria workers or the cafeteria also needs janitorial services, and the janitorial employees also eat in the cafeteria. So they do support each other, but we're going to decide in which order to allocate them. And there's no wrong answer. So we could decide to allocate the janitorial department to the remaining departments. So that would be the first step. And that would look like this. If I can arrow back here. So the 310,000 from the janitorial would go to the cafeteria and to the cutting department and to the assembly department. And now the janitorial 310,000 is fully allocated to those other three departments. The cafeteria department cost includes this 169 plus a piece of the janitorial. And then we would take the cafeteria department cost, again, the 169 plus whatever came from janitorial, and we would allocate that to the remaining departments, which happen to be just the production departments. So that's the step down. We recognize that the support departments use services from other support departments. And we decide which one to allocate first. And it might be the one that gets the most usage by the other support departments. It might be based on dollar amounts, the highest dollar amount, like here, janitorial costs more, so let's allocate that first. There's really no wrong answer to the ordering. And anything that we do for class, you will be told which order to use. Okay, so you're not going to have to figure that out, because you will get at least slightly different answers if you allocate them in one order compared to the other order. So those are the two that we've already covered. Those are the two that are the simplest, and those are the two that you should have already reviewed in exercises 4 and 5. Now we go to the one that's the more challenging, the reciprocal services method. And again, for this method, we recognize that the support departments not only support production departments, but they support each other. And so you end up with something that looks like this. The janitorial department and the cafeteria department not only get allocated to the production departments, but they each get allocated to each other. And so we recognize that the janitorial department total cost is the 310,000 plus some part of the cafeteria. And the cafeteria total costs are the 169 plus some part of the janitorial. Because of that reciprocal, because of that two-headed arrow that I just put on the screen, we can't solve this directly. We have to set up a system of equations with those two variables to figure out what is the total cost for those two departments. And that's what we're going to do next. So we'll start out, and I'm just going to use J for janitorial and C for cafeteria, just to make sure my equations don't get too long. Maybe I'll do this, Jan and Caf. How's that? So the janitorial department cost is, and I just said this in words, but now I'm going to put what I just said into a mathematical equation. The janitorial cost is the 310,000 direct cost plus some portion, and for now I'm just going to put a blank there because I don't know yet how much, some portion of the cafeteria's cost. Okay. And the cafeteria's cost is the 169,000 of direct cost plus some portion of the janitorial cost. Everyone okay with where those equations are coming from, even though we don't have the numbers yet, the percentages or the portion? Any questions about where those came from? Okay. So the janitorial department, we're told, is going to be allocated based on square footage to be serviced. That makes sense. The more space there is, the more time, the more cost it's going to be to clean it, to keep it sanitary, whatever. So we're looking for what portion of the janitorial cost is used by the cafeteria. So let's look at the square footage for the cafeteria along with the cutting and assembly department. And I don't want to finalize what I have written on the screen yet, so I'm just going to talk this through. So to allocate the janitorial department, we're going to look at the square footage of the other three departments, 5,000 plus 1,000 plus 4,000. That's 10,000 total square feet. And the cafeteria is 5,000 of the 10,000. That's half, or 50%. So half of the janitorial cost is going to go to the cafeteria because it's half of the space that the janitorial department has to clean, service. Does that make sense? Anyone with questions about where that came from? Now to fill in this other blank, let's look at the cafeteria department. And it tells us right here that the cafeteria department is going to be allocated based on the number of employees. That makes sense. The more employees, the more use they're probably making of the cafeteria. So we're going to ignore the staff of the cafeteria. We're not allocating cafeteria costs to the cafeteria. We're not allocating janitorial costs to the janitorial department. Instead, we're allocating each of those costs to the other support department and the production departments, but not to itself. So if we look at the total employees, ignoring the cafeteria employees, we have 10 in janitorial, plus 30 in the cutting department, and 10 in assembly. That's a total of 50 employees. And the janitorial department is 10 of those 50. That's 1/5 or 20%. If you don't like percentages, you're welcome to use decimals, you're welcome to use fractions. From a math standpoint, 10/50ths, 1/5, 20%, 0.2, those are all the same number. They're just expressed in a different way. So if you don't like percentages, that's fine. You don't have to use them. You can use the decimal, you can use the fraction, you'll get exactly the same answer. So there's our system of equations. We have two equations, each with two variables. Is there any question on this? Okay, now we just need to substitute one into the other, and this is where I need to give you the same warning I said last week. Depending on how you round, your answer could end up a little bit off. Depending on which of these you substitute into the other, your answer could end up a little bit off based on rounding from the answer that the software has. So if you think you've gone through this and you've done everything correctly, and you end up with an answer that does not show as being correct, and specifically I'm referring to the homework problem where you can check that, just send me a note. Try it the other way around. Try substituting the other equation first and see if that changes your answers. It will, depending on how you round. And the only reason I'm saying that is I saw it happen last semester with one student who had done everything correctly, but she substituted the equations in the opposite order and then rounded, and she was doing everything right, and it looked like her answer wasn't right. And guess what? She still got credit because she brought it to my attention and I checked it for her and said, yeah, you're doing it correctly. You get full credit for that. But I have to know what happened. So if you run into difficulty like that, just let me know. Try it the other way if you need it. Okay, so now we're going to substitute. And we will substitute let's substitute the second equation into the first. So where I have cafeteria in the first equation, I'm just going to plug in the quantity from the second equation. The cafeteria is 169,000 plus 50% of the janitorial cost. So janitorial equals 310,000 plus 20%. And then we're going to plug in give myself a little more room here. We're going to plug in that second equation. Make sure you put it in parentheses, so you've got the whole quantity times the 20%. And then it's just a matter of solving. Now we have our equation with just one variable and we can solve for that variable. So this is the algebra part. I'm going to distribute the 20% to get rid of those, remember PEMDAS? Hopefully, remember PEMDAS?
You wanted 310.
Did I? Oh my word. Yeah, thank you. Thank you. That would have been very tragic if I got through the whole thing and then realized I copied my equation wrong. So I'm distributing the 20% inside the parentheses. So 20% of 169 is 33,800. And then 20% times 50% is 0.1, or 10% times January. I just said January, janitorial. Obviously, Jan is a much more common abbreviation for January than janitorial. Going to combine like terms. So if I subtract 10% of January from both sides, we end up with 90%. 90% of janitorial. Maybe if I do that. 90% of janitorial, and then 310 plus 33.8 is 343.8. So now how do we get janitorial by itself? We do, it's 90% time. So if we divide by each side by 90%, we will get janitorial is 343.8 divided by 0.9 or 90%. So the full cost of the to run the janitorial department includes the $310,000 in direct costs plus part of the cafeteria cost for a total of $382,000. We can then find the cafeteria cost by going back to our original equation. Cafeteria is, second line at the top of the screen, 169 plus 50% of the janitorial, which we now know is 382. And then just solve that. Half of the janitorial is 191 plus the 169,000 in direct costs. The cafeteria is $360,000. Okay. Everybody okay up to this point? Okay. So now what we are going to do is allocate the janitorial and the cafeteria to the production departments. So the cutting department, janitorial is being allocated based on square footage. The cutting department is 1,000 of the 10,000 total square feet. So the cutting department, whoops, get rid of that. Oh, maybe I better put this calculation on the screen. So the cutting department is 1,000 of the 10,000 total square feet. So that's 10%. And the assembly department is 4,000 of the total 10,000. So that's 40%. Oops. So, oops. So the total janitorial cost was $382,000. We're going to give 10% of that, or $38,200, to the cutting department. And we're going to give 40% of that, $382,000 times 40%, 152,800 goes to the assembly department. What happened to the rest of it? We allocated it to the cafeteria. And it will get allocated from the cafeteria to the two production departments. The cafeteria gets allocated based on employees. And the cutting department is 30 of the 50 employees. That's 3/5 or 60%. And then the assembly department is 10 of the 50 employees or 20%. And so the 360,000 for the cafeteria, whoops, 360,000, 60% of that goes to the cutting department. 60% of 360,000 is 216. And then the cafeteria, 360,000 times 20% goes to the assembly department. How'd we do? This makes, go ahead. Are you, I missed the beginning of it. So are you asking what, where did those percentages come from or what did we do with them? Yeah, so let me show you that. It's a good question. So, and I think that may help to clarify this a little bit. So the janitorial gets an allocation from the cafeteria. And right here, right here, the 20% times cafeteria is how much got allocated to janitorial. So 20% of the 360,000, 20% of the 360,000 is 72,000. So 72,000 of the cafeteria got allocated to janitorial. That's how the janitorial got from 310 up to 382. Because this 382 right here includes the direct cost of 310 plus 20% of the cafeteria, or 72,000. And the same thing happened for the cafeteria. It got an allocation from janitorial. It got 50% of the janitorial. Janitorial is 382,000. 50% of that is 191,000. So that's how the total for the cafeteria went from 169 up to 360 because of the 50% of the total janitorial. That's what makes this complicated, because it's not 50% of the direct costs of 310. It's the 50% of the total cost. Did that answer your question, JP?
I was asking about like the 10% and 60%. Once you know to
Where did these percentages come from?
10% by the total janitorial cost to get the final answer. Where does 10% come from?
So where did this 10% come from? It came from the same place that this 20% and this 50% came from. So we look up here, the janitorial department is allocated based on square footage. And we're going to ignore the square footage for the janitorial department because we don't allocate it to itself. So we only look at the other departments right here. There's our total square footage. Whoops, sorry. There's our total square footage, 10,000, 5 plus 1 plus 4, 10,000. And the cutting department is 1,000 of those 10,000. That's the 10% here. And the assembly department is 4,000 of the 10,000. That's this 40,000 or 40%, excuse me. The cafeteria department is allocated based on number of employees. Again, we're going to ignore the number of employees in the cafeteria because we're not allocating it to itself. We're only looking at the other departments. So we've got 10 here plus 30 and 10. So that's a total of 50 employees. The cutting department is 30 of those 50 or 60%. And the assembly department is 10 of the 50 or 20%. I get that this is challenging. I really do. That's why. And I don't want anyone to feel like you're lost even if you don't get this problem. That's why it's not on the exam. I feel it's important. I think it's important to show you and for you to understand the concept of allocating the support departments to all the other departments. But doing the actual calculations is challenging. And the more departments we throw in there, the more challenging this becomes. And so that is why it's not on the exam. Okay. Are we okay to move on? Right. As I said, if you get stuck, if you have questions when you're working on the problem, you do have the tutorial. If you have questions while you're working on the extra credit, let me know. I'm happy to help with this. I'm not going to do it for you, but I'm
Is there
happy to
a-
help you.
Is there a time limit on that credit?
There's-
Set up like
no,
a test or
No, good question. There is no time limit on the extra credit.
so it's set up like one of the end of chapter problems?
Yeah. And if you would feel comfortable doing the extra credit now, I think I said this last week, it's open now. And so while it's fresh in your mind, if you want to work on it now, you're welcome to do that. Yep. But it's extra credit. You don't have to do it at all if you prefer to just put it behind you. That's okay. And so we're done with the first half of the chapter, which is allocating those support departments using the 3 methods. So you are responsible for knowing how to do direct and step down. You do not have to be able to use the reciprocal method on the test, although a multiple choice question about it would be a fair game. You know, to understand the why part and what it is we're doing, even if you can't do the algebra piece of it. Excuse me. And so we're moving to the other part of the chapter, and that is allocating joint costs. Last week, I gave you a bit of a heads up about what we were talking about when in the manufacturing process, at the beginning of the process, things are happening to multiple products, but as one step in the process, as you can see in this visual. So the costs here of stage 1, 2, and 3 of this manufacturing process, we have to have a way of assigning those costs so that they get to both of the products. So there's a split off point where we start working on them independently or separately. And so we can determine separately the cost of the 4th and 5th step for each of those products because they're different for the 2 products. But we have to have a way of taking these joint costs, the costs that are incurred for all of the products, and dividing them up across the products. As I said, we're going to be covering 4 different methods. You're responsible for all 4 of the methods. The physical units method is probably the easiest to implement. And just as I said, for the 3 methods for allocating support department costs, we only want to make it harder for ourselves if it gives us better information to make better decisions about managing and running our company. We want to use the simplest method possible that still gives us accurate or valid information for decision making. So in the remaining 4 exercises for this chapter, we're going to be going through in each exercise one of these methods. So you'll see how to use all 4 methods. And we'll start with the physical units method. As you can see on the screen, the physical units method allocates those costs using a physical measure of the products, ounces, pounds, feet, whatever it is. I think this is a funny slide because I've actually been to the Dead Sea, and it is right before COVID hit. That was my last international trip for a very long time. And they do use and sell the mud from the Dead Sea as part of the, as like a skincare, health related kind of thing. So I thought that was funny when I saw this slide. So in the physical units method, we would just have some way of measuring all of the products based on some units, ounces, pounds, feet, acres, whatever. You have to be able to measure the products in the same units, or else we can't do this allocation. Let's go to our next exercise. And in exercise 7, we're going to be using that physical units method. Boarded Incorporated produces the following types of 2x4x10 wood boards: washed, stained, and pressure treated. So the boards are produced jointly until they're cut, and we end up with a bunch of 2x4x10 boards, and we decide that some of them are just going to get washed, others will get stained, and then some will be pressure treated. So the cost of getting it to the point that they're cut, and then we differentiate between the three products, the total cost is $710 per batch. And the batch produces, here are the numbers, the batch produces 45 plus 35 plus 20 total boards. So we have $710 per batch, and that is for 45 plus 35 plus 20 boards. Everyone see that? So it's a total of 100 boards. $710 divided by 100 boards is $7.10 per board. And we're going to allocate this based on the number of boards. So we're assuming that the cost for each type of board is the same up to that point. And then we can add on the cost for washing the boards to the washed boards, and staining the boards to the stained boards, and pressure treating the boards to the pressure treated boards. But up to that point, we assume that each board costs $7.10 to produce. So how many washed boards? 45 washed boards at $7.10 each. It says round your answer to 2 decimal places, so we're going out to the cents. $7.10 per board for 45 washed boards. 35 stained boards at $7.10 each. And then 20 pressure treated boards at $7.10 each. So what do we want the total to be? Well, the total better be the $710 that we're trying to allocate. If not, we've done something wrong. Under all of the methods, the end result must be that we have fully allocated those joint costs to the separate products. So the end result in total is the same. That's why I said it doesn't matter which, from an accounting standpoint, we can use any one of these methods, because the end result is the same, that we have taken our total cost of, in this case, $710, and divvied it up among the products that we produce. So there's no wrong answer. There are simply answers that give us better management information. I just had to check it to make sure it did work out, and it does. So there's no wrong answer. There's no reason that we can't use this physical units method. In this case, it seems to make sense because the products are exactly the same until that split off point. And then we're just treating them differently. And how we treat them after that split off point, we'll add those costs separately to each one of the 3 different treatments. It could be that all the boards get washed and then some stop. It could be that after they're washed, we then stain some of them. I don't know. And then it could be that, well, probably not pressure treating them after we stain them. It could be that some of the washboards then are pressure treated. My guess is, as I'm thinking about this, we probably don't wash all of them, because if we did, we would just count that as part of the joint cost. That would be easiest. So as I said, the physical units method is definitely the easiest, most straightforward, probably the easiest to understand, the simplest math. So if this gives us useful information for managing our company, we would just do this because it's easy. Not suggesting we're lazy. I'm suggesting we're trying to be efficient. Any question about the physical units method? Let's keep going then. Our next exercise, excuse me, exercise 8 is the weighted average method. Excuse me, apologize. Our next method is the weighted average method. And so we are going to apply weights based on the relative work involved. So of those 3 products that we were looking at in the last exercise, it could be that one of them, for some reason, takes more work in that joint cost, or it's a harder process. And so we would want to weight that more heavily. We'd want to assign more cost to it. For our purposes, you are not going to have to determine what the weighting factors are. We will be told that in any exercise or problem that you have to do. And that's really the hard part, is determining what weight should we be applying here. So if this was a real situation where you had to figure that out, that's the more difficult part. You can see down here in the final bullet point some of the factors that might influence the weights that we apply. Type of labor needed, difficulty of producing each product, estimated wear and tear on machines caused by each product. So some products might be harder, and so they cause more wear and tear. And so we'd want to assign them more cost. Okay. So we're not going to go through that example. We are going to go to our exercise. Here we go. And look at this. So the process is mostly the same as what we did in the previous exercise, except now we're going to assign a weight factor. So I'm going to set up a table here. I think that'll be the easiest way to see this. Just extend this line here so I can set up my table. And we'll switch over to text. Carving Creations jointly produces wood chips and sawdust used in agriculture. The wood chips and sawdust are actually byproducts of the company's core operations, but Carving Creations accounts for them just like normally produced goods because of their large volumes. One jointly produced batch yields 3,000 cubic yards of wood chips. So let me put this here. So volume, 3,000 cubic yards of wood chips and 10,000 cubic yards of sawdust. Okay. That's how much we're producing. And the estimated cost per batch is $21,400. So at the end of the problem, the end of this exercise, we want to be allocating that $21,400. So we're going to be splitting that between sawdust and wood chips. If we just use and now I can't think what we called it in the last exercise, the direct method. Physical units method, I apologize, just totally drew a blank. If we just use the physical units method, we would simply add the 10,000 plus 3,000 and say, okay, it's 13,000 cubic yards. 10 of the 13, 10/13 of the cost goes to sawdust and 3/13 goes to wood chips. That would be the physical units method. We base it on the 10 and 3,000 cubic yards respectively. However, we keep reading the exercise. However, the joint production of each good is not equally weighted. Management at Carving Creations estimates that for the time it takes to produce 10 cubic yards of wood chips, only 2 cubic yards of sawdust is produced. And so those are our weights. We spend more time producing the wood chips, and so it gets a heavier or a higher weight. It's going to get more of the cost because it takes more of the time. So based on what it said, 2 cubic yards of sawdust to 10 cubic yards of wood chips. Those are our weights. These are ratios, 2 to 10. We could use 1 to 5. Mathematically, it'd be exactly the same thing. I'm going to leave it at 2 to 10 because those are the numbers that are given to us. However, I want you to realize, you can shape, without changing the ratio, you can simplify those numbers. 2 to 10 is the same as 1 to 5. So let's put a line under that, and we'll total those. Oops, sorry, I'm just trying to get that line straight. Here we go. So out of a total of 12, we have 2 and 10, so we can change those into percentages, just because that might be easier for us to work with. So 2 out of 12. Actually, let me not do the percentages yet. Scratch that. Let's apply the weights next. Again, mathematically, we could do this in either order, but I'll apply the weights next since that's the way I've set up the columns. So the next column I'm going to call weighted volume. I'm going to multiply by the weights. 2 times 10,000 would be 20,000. 10 times 3,000 would be 30,000. So the total, 50,000. Oops, 50,000. You can do the calculation at this point if you'd like, or you can change those into percentages. And it matters not to me. It's, excuse me, mathematically, again, it's the same thing. But as I said a moment ago, we're used to seeing things maybe as percentages. So I'm going to go ahead and stick those percentages in. So as we look at the time that we're spending on producing these products, if we produce 10,000 cubic yards of sawdust, and it takes, if it takes, let's say, 2 hours to produce that, that would be a weighted volume of 20,000. The weight on the wood chips is 10, so 10 times 3,000. The weighted time is 30,000. So now we can calculate the percentages of our time that are being spent on those. 20 out of 50 is 40%. 30 out of 50 is 60%. Okay, we didn't have to do the math in this order, but I'm giving you a format to maybe help you think about it in a step-by-step or logical approach. So 40% of the time spent on sawdust, we're going to allocate 40% of the cost. 40% of the joint costs of 21,400 is $85.60. We know that what we're trying to allocate is the $21,400. And allocate 40% of that cost to sawdust, and the other 60% will go to wood chips. That's what we needed to do for this exercise, but I want to show you one more thing.
Did you just multiply the weighted volume as a percentage, or?
I multiplied the percentage times the 21,400, which is the joint cost we're trying to allocate. So I want to show you what the unit cost would be. So for sawdust, we've allocated $8,560, and that's for the 10,000 cubic yards. And so, oops, sorry. Probably an abbreviation for cubic yard that doesn't involve the superscript, but I don't know what it is. So we end up with a cost per cubic yard of sawdust of 85.5 cents roughly. I just took the total cost that we allocated to sawdust and divided by the volume to get the cost per cubic yard. I'm going to do the same thing for wood chips. We allocated more cost to wood chips, and we end up with less product. So we're going to end up with a higher cost per unit of the product. Whoops. We end up with a cost of $4.28 per cubic yard. It's about 5 times more expensive to produce the wood chips than to produce the sawdust. And that makes sense based on what we are told here. The time it takes to produce 10 The time it takes to produce 10 cubic yards of wood chips, only 2 cubic yards of sawdust is produced. It takes 5 times as much time. And so the wood chips are more expensive than the sawdust. So I would recommend that you follow a format similar to this. It is also included in your book. Whoops, if I were to clear off those drawings. So here's an example of what we just did. This also appears in your book. So if you want to see kind of the format for setting that up, I would encourage you to follow the same type of format just to keep your calculations or your thoughts in order. All right. Our next, any questions before we move on to our third method? Our next method is the market value at split off method. And this is going to be in exercise 9, the market value at split off. I don't necessarily, this isn't going to come out right. I don't necessarily approve of this method because the rationale behind this method is if it's worth more at the end, we should allocate more cost to it. So kind of the idea is keeping our profit margins similar across various products. And I don't necessarily think that's the best way to think about it. But it is a legitimate way, it is an acceptable way of allocating those joint costs. Again, there's no, the rationale is, well, it's worth more at the end, so we just give it more cost. I don't really like that, but I'm not passing judgment on this method. I'm just not sure that's the best way, other than it keeps our profit margins across products relatively more equal, equitable. So products that have a higher market value are allocated more of the joint cost. Let's go to our exercise. Go. And we're going to do something similar. We're going to set up a similar type of table to do these calculations. I'll go ahead and get that table started here. Just going to extend this line. Sugar Sweetheart Incorporated jointly produces raw sugar, granulated sugar, and castor sugar. So if you're not familiar with the term castor sugar, it is similar to the concept of what we call confectioner's sugar, that it is a more highly blended, so it's finer, it's between regular sugar and confectioner's sugar. So it's finer than regular sugar, but not as fine as confectioner's sugar. After the split off point, raw sugar is immediately sold for 20 cents per pound, while granulated and castor sugar are processed further. So this is at the split off point. If we use the physical units method, we would simply, how many pounds went to this, how many pounds went to that, how many pounds went to the other, and that's how we'll split up the cost. Under the market value at split off, we are going to use the value of the product. If it's worth more at split off, even though it's exactly the same product at the split off point, right? So the raw sugar at the split off point, it's all raw sugar. But because some of the product we're going to take and refine more, and it's then going to be worth more, we're going to assign it more of those upfront costs. Again, I'm not a big fan of this approach. One second here. I'm not a big fan of this approach, but it is definitely used. Okay. Had to make a note there. So the market value of the granulated and sugar and castor sugar is estimated to both be 25 cents at the split off point. One batch of joint production costs $1,640. So that's what we are going to allocate, $1,640, and that is the cost to get the sugar cane, the raw materials, into raw sugar. Okay. And so sorry, let me get my pages straight here. So the market value at that split off point is determined to be 20 cents for the raw sugar, 25 cents for the other two products. So the total market value, based on the number of pounds we produce, so that those are the per pound. So the total market value, whoops, give myself enough room here. The total market value, raw sugar, we have 3,000 pounds. 3,000 pounds of raw sugar at 20 cents per pound. The total market value then is $600. Granulated sugar, 3,600 pounds. Now, I want to point out, the company decides how to split this up. If there was a market, they could just sell it all as raw sugar if they wanted to. They don't, because it's more value for them to continue to refine the product and sell some of it at a higher price. The castor sugar and the granulated sugar. We will, in an upcoming chapter, we'll be talking about, well, does it make sense to even keep processing it? And the end result, or the final decision is, well, do we get enough more if we continue to refine it? We're going to incur extra cost to continue to refine it, but is it worth more after that refining than it cost us? It's a kind of a cost benefit analysis, if you want to look at it that way. But I just wanted to point out that the company makes the decision to continue to refine part of the product. And the way they make that decision is based on how much can they sell and which one's more profitable. So if the castor sugar is the most profitable, they would probably produce as much of that as they can. They'd prefer to sell it all as castor sugar if that makes them more money in the long run. The only reason they're splitting it is because that's where the market demand is. Okay. 2,000 pounds of castor sugar at a value of 25 cents per pound. That's a total of $500. So now we can total those to get our total market value. Okay, 600 plus 900 plus 500 is a total value of $2,000. So we're going to allocate the cost based on this total market value at the split off. To be consistent, we're going to calculate the percentages and enter them here. Oops. Why did you not? Percentages, there we go. So the raw sugar is 600 of the $2,000 total market value, that's 30%. The granulated sugar is 900 of the total 2,000, and that's 45%. These percentages, of course, need to add up to 100. So you want to check that, make sure you've done your math correctly. They need to add up to 100%. Those are the percentages, just like in the last exercise, those are the percentages we're going to use to allocate these total joint costs. So of the $1,640, 30% is going to be allocated to raw sugar for $492. 45% will be allocated to the granulated sugar, and 25% to the castor sugar. And then just check your math to make sure you have fully allocated. We already knew what the total needed to be, and we just want to make sure we have allocated fully those joint costs. So if you were to calculate, I'm not going to go through it, but if you were to, at this point, calculate the cost per pound for the raw sugar, the granulated, and the castor sugar, you would find that we're allocating a lower cost. Actually, I might as well just do that. We've got time. Let me just show you in numbers. So the cost per pound. So $492 for the raw sugar, and that's for 3,000 pounds. Ends up being 16.4 cents per pound. We can sell it for 20 cents per pound. So the gross margin on that product is about 3.5 cents per pound. Granulated sugar, we've allocated $738. And that's for 3,600 pounds. for a cost of 20.5 cents per pound. And a gross margin of 4.5 cents. So as a percentage, it ends up being about the same. And the castor sugar, $410 in joint costs allocated for the 2,000 pounds. And as we would have expected, this should be the case, the cost per pound for the castor sugar is the same as the granulated sugar. Why? Because we said right here that the market value per pound was the same. So it gets allocated the same relative cost, the same cost per pound. Oops. Allocation amount. This column right here, Seth, is that what you mean?
Yeah.
Okay, so did you understand? So the market price was given. We found the total market value by multiplying the market price per pound by the number of pounds that were given up here for each one of the three products. So we ended up with this total market price or value for each of the three products, total of $2,000. We found the percentage by dividing its portion, $600 of that total market value is for raw sugar, 600 out of the 2,000, that's 30%. Okay, so that's how we got the percentages. 900 divided by 2,000 is 45, 500 divided by 2,000 is 25. Now we know the percentages of the total market value at split off method for each one of the three products. So we took the joint costs to be allocated, given right here, one batch of joint production costs, $1,640. That's how much we needed to allocate, and we're going to allocate them based on the percentages in this column. So for raw sugar, it's 30% of the total value times the $1,640 in total cost is the $492. For granulated sugar, it would be 45% of the total value. So we're going to give it 45% of the total cost. And castor sugar, 25% of the total value. So we're giving it 25% of the total cost. 25% of 1640 is the 410 that we have here.
That makes sense.
Okay, so I just want to reiterate. The company made the decision of how to split up that production. They decided to produce from the roughly 8,600 pounds worth of sugar that they were going to end up with. They decided how much of it would be left as raw sugar and how much would be processed further. And of the part that was processed further, they decided how much would become granulated and how much would become castor sugar. That is a decision for this company based on this product. For some companies, that's not true at all. And as I said last week, my frame of reference is the refinery where I used to work as a cost accountant. At the refinery, when you're refining crude oil, you don't get to decide how much of it is each of the components that it gets separated into. It is what it is. You know, you start with the crude oil and you separate it into the various products. So again, for this company, they made a decision about how to split it up. For other companies, it's not a choice. It's what you end up with. Depends on the raw material, what you end up with. As I suggested, I don't necessarily agree with the rationale, and I understand why. I understand how to do it. I don't know why you would do this other than it helps to maintain a more equal margin across, as far as percentages, across the products. From an accounting standpoint, you are allowed to use this because either way, the total cost ends up being reported, right? So we're not leaving some cost out. The total cost ends up being reported I just don't happen to care for it because it might skew your decision-making because the costs up to that point are exactly the same for all three products. So. And we've just suggested here that the cost for granulated and castor sugar up to that point is actually higher. It's not, it's exactly the same product. It's all raw sugar at that point.
One more question.
Yeah.
Just how do we get the total market value for?
Yeah. So the question in the classroom was, how do we get the total market value? So we were told here in the exercise that at the split off point, raw sugar can be sold for 20 cents a pound. But they estimate the value of the granulated and castor sugar to be 25 cents per pound at that split off point. So that's where the unit market value came from. It was given to us. So then we find the total market value by taking the total pounds that are going to be produced of each of the products and multiplying by its market value. So for raw sugar, 3,000 pounds at 20 cents per pound is the $600. For granulated sugar, we're going to produce 3,600 pounds at 25 cents per pound, that's the $900. And finally, 2,000 pounds of castor sugar at 25 cents per pound is the $500. Make sense? Okay. If there aren't any other questions, anybody else? We'll go to our final method. Oops, let me get the blue stuff off the screen. Okay, we'll go to our final method. There it is. So the net realizable value is our final method and our final exercise to finish up this chapter. So in the previous exercise, we used the net market value at the split off. For this exercise, we go to the end product and say, okay, how much is it going to be worth when we're done with it? And we use that as our way of allocating out the cost. Again, I'm not sure from a management standpoint, I'm not sure why this is more helpful for decision making, because what it does is take those joint costs that may be exactly the same for each one of the products and say we're going to allocate some of them more to some of the products because they end up being worth more at the end. I'm just not a big fan of that rationale, but it is perfectly fine. It's not unethical or anything like that because all of the cost ends up being reported. So this is more work than the physical units method where we started. I'm sure that I'm just not, there must be some reason I'm just not thinking of that it makes sense for a company to go through this extra work. But what it does, as I suggested in the last exercise, is help you to maintain a more consistent margin, profit margin as a percentage across the products. Let's go to our last exercise then. We've got another exercise where they're producing wood products. Nature's Garden Incorporated produces wood chips, wood pulp, and mulch. These products are produced through harvesting trees and sending the logs through a wood chipper machine. One batch of logs produces 20,304 cubic yards of wood chips, 14,100 cubic yards of mulch, 9,024 cubic yards of wood pulp. The total joint production process costs $32,000 per batch. Okay. So this may be a situation like what I was describing for the refinery in the previous exercise. They may not be able to control the split between these products. You put the logs through the chipper and some of it's gonna come out as chips and some of it's gonna come out as mulch and some of it's gonna come out as pulp. And that's what we're stuck with, if you will. Here we go. The market value, hang on a second, let me go back. After the split off point, wood chips are immediately sold for $25 per cubic yard, where wood pulp and mulch are processed further. The market value of the wood pulp and mulch at the split off point is estimated to be $22 and $24 per cubic yard respectively. So if we were using the previous method, the market value at split off point, those numbers would be relevant. For our exercise though, we're looking at the end result, the net realizable value when we sell it to the customer. The additional production process of the wood pulp costs $5 per cubic yard, after which it is sold for $30 per cubic yard. So let me point out to you this word, which is key, the net realizable value. The value we can realize after we take into account the additional cost. So let me, whoops, extend our line here so we can set up our table, and we'll get started with this in a moment. The additional production process of the mulch costs $4 per cubic yard, after which it is sold for $32. Okay, so let's start our table here for calculations. Again, you'll find a table similar to this, what I'm constructing here, you'll find in your book if you're looking for that. How do I even begin setting this up? So we start with the market value at split off. I can't put all the labels in here, I just don't have enough room. So the market value at the split off, $25 for wood chips, but because the wood pulp, the wood pulp is 24 and the wood pulp is 22 and the mulch is 24. My assumption is they've gone beyond being able to be sold as wood chips, that they're too small to be considered wood chips. So we're going to use them, we're going to make them into something else so that we can still sell them, so they're not a byproduct per se. So there's our market value at split off. But let's go, how much more does it cost? So I'm just going to label this additional cost of production. The wood chips are sold immediately, so there's no additional cost. The wood pulp costs an extra $5 and the mulch costs an extra $4. We can sell them. I know I'm labeling this market again, but this is the market at the end result, the end value. The market price at the end is, we already know it's 25 for wood chips because we're not doing anything more to that. The wood pulp costs $30, we can sell for $30, and the mulch we can sell for $32. So the net realizable value for our wood chips doesn't cost us any more. So it's $25. The wood pulp we can sell for $30, but it costs us an extra $5 to get it ready. So it's also net realizable $25. The mulch we can sell for $32, but it costs us an extra $4 to process it. So the net realizable value, the actual amount we would realize after that additional processing cost, is $28. So let's look at next, how much can we sell this for in total? Let's see, total column. Our wood chips, we can sell them for a net realizable value of $25. how many wood chips do we end up with? 20,000 right here. 20,304 cubic yards of wood chips. 20,304 cubic yards of wood chips. We're going to sell them for $25 each. That's a total of $507,600. Run out of room. Everyone okay where these numbers are coming from?
not
Or-
really.
Okay. Where did I lose you, Seth?
I I'm just not getting how you came up with that 507,000.
The 5,700, okay. So the 507,600, but you're okay with up to that point where these numbers came from? The net,
Yeah,
okay.
yeah,
So we're told right here in line 2, right where I'm circling with my cursor right now, one batch produces 20,304 cubic yards of wood chips. We can sell each one of those for $25. So 20,304 cubic yards at $25 each. That's where the 507,600 came from.
now I gotcha.
Let's look at the mulch then. 14,100 cubic yards of mulch, we're told in the beginning of line 3.
We're doing the mulch or the pulp?
Oh, sorry, they have them in, thank you. They have,
And then I was gonna ask for the pulp, how do you get the 25 per knot?
because we can sell them for $30, but it costs us an extra $5 of processing. Did I do those? No, I did that right. So the additional production process of the wood pulp costs $5, after which it can be sold for $30.
Okay,
we
but
can sell it
starts at 22, right?
That's the at split off, but
Okay,
we're looking at the end result now.
okay,
We're not using, so
all right.
good question. So this first column is the market value at split off. Right now, we're not looking at that. We're only looking at the end product, the net realizable value at the end of the processing.
Okay.
Makes sense? Okay. So wood pulp, we have 14,100 cubic yards of, oh yeah, let me just clear my calculator. We'll do the wood pulp. I'm sorry, they have them in the opposite order. So let's go to wood pulp next because that's what's next in our table. 9,024 cubic yards of wood pulp in line 3. 9,024 cubic yards of wood pulp. And our net realizable value after the extra processing is $25. So that's a total of $225,600. Last, our mulch, 14,100 cubic yards of mulch at $28 net realizable value after we pay for the extra processing. And there's our totals. So let's total those up to find out the total revenues we're going to get, net revenues after we pay for the additional processing. And you guys are sitting pretty still. So the net realizable value, $1,128,000. How much we can sell it for at the end minus the extra or additional processing that we'd have to pay. And from that we can calculate the percentage of for each one of our products, just as we have done in all of the methods, but what we're comparing is different for each one of the methods. Here we're looking at the end value. In exercise 9, we looked at the value at the split off. In exercise 7, we looked at just the physical units. And in exercise 8, we assigned a weight to those physical units based on the work that went into producing them. So now I'm just calculating the percentages. The total dollar in our next to the last column right here, the column we just did, $507,600 out of $1,128,000, that's 45%. Wood chips represent 45% of that net realizable value when we sell them to the consumer. For wood pulp, 225,600 divided by 1,128,000, that's 20%. And for the mulch, 394,800 divided by 1,128,000, 35%. And as we said in the previous exercises, just want to check and make sure that you have 100% of the value there for the cost. Because those are percentages that we're going to use to allocate these joint costs, $32,000. 45% of the $32,000 is going to go to the wood chips because they represent 45% of the net realizable value when we sell them. So 32,000 times 45%, 14,400. The wood pulp is going to get 20% of those costs. And the mulch is going to get 35%. As I suggested, I would recommend that you follow a setup like what's here, like what you'll find in your book to set up the table so that you can think through each one of these steps. There's no magic answer for which one of these 4 approaches for allocating joint costs is better. As I've suggested many times now throughout this chapter, my inclination is to use the simplest one that gives us the best information to make our decisions. Unfortunately, what that means, sometimes the best information comes from the most complicated method. And so we have to make, we have to weigh the extra work with the extra benefit of getting better information to help us make decisions. We are out of time. It's 10:40. We are done with this chapter. Perfect time. Any questions before I stop the recording?
Just question 4 and 5. Just like I totally forgot to do them, but I never got the quick recap on how to do it.